Hello, in this video I'm going to teach you how to solve a pair of simultaneous equations using what's called the elimination method, and you'll see why it's called that, but basically we're going to eliminate either the x or y variable to make an equation that's pretty easy to solve. So let's take a look at this first example, and the first thing you're going to want to do is label the equations up. So we've got equation 1 and equation 2. The next thing you want to do is choose a variable, so either x or y, and you want to make the coefficient of that variable the same in both equations. So I'll pick equation y, and you can see I don't actually have to do anything because it's already got the same coefficient. They're 1 in equation 1 and 2. So the coefficient of y is already the same. So once I've done that, all I really have to do is subtract one equation from the other. So let's do equation 1 subtract equation 2. And if I do that, well, we get 2x subtract x, which leaves me with 1x. So we've got x. Then we can do y subtract y, and you can see we've got 0y. So that's nothing, and that's going to equal 10 subtract 7, which leaves me with 3. So you can see I've eliminated the y variables, and because the coefficients were the same, that's why they were eliminated. And we're left with x equals 3. So now I know the value of x that solves these equations. How can I use it to help me? All I have to do is substitute x equals 3 either into equation 1 or equation 2. It's up to you. I think equation 2 looks easier, so I'll do that one. And so wherever there's an x in equation 2, I'll write 3. So we get 3 plus y equals 7. And so now I can just solve this. I just have to subtract 3 from both sides like this, and we get y equals 4. So now I've found the two solutions that solve my simultaneous equations. We've got x equals 3 and y equals 4. And so these are the solutions to the pair of simultaneous equations. So that was pretty easy. Okay, so this second pair, we've got 4x plus 2y equals 22 and x plus y equals 9. So again, I'm going to label them equation 1 and equation 2 like that. And now I'm going to pick one of my variables, either the x variables or the y variables, and I want to make the coefficient of them the same in equation 1 and 2. So I'm going to pick y again because I did last time. So we've got y, and you can see in the first equation the coefficient of y is 2, but in the second equation the coefficient of y is 1. So to make them the same, I'm going to multiply everything in equation 2 by 2. So 2 times equation 2, and that's going to give me 2x plus 2y equals 18. So now I've done that, you can see, well, let's call this new equation, equation 3. And now I've done that, you can see that the coefficient of y in equation 1 and in equation 3 is the same. So what I'm going to do is do equation 1 subtract equation 3, because that will eliminate the y variable again. So equation 1 subtract equation 3. Well, when I do that, let's get rid of this. We're going to do 4x subtract 2x, which leaves me with 2x. So we've got 2x. And then we're going to do 2y subtract 2y, which leaves me with 0. So we've eliminated the y's. And that's going to be equal to 22 subtract 18, which is 4. So now I can divide both sides of the equation by 2, and I get x is equal to 2. And so once again, I can substitute x equals 2 into either equation 1 or equation 2, and it will tell me the value of y. So because it's easier, I'll substitute it into here, equation 2, and we get 2 plus y equals 7. And subtracting 2 from both sides gives me that y, oh, I answered it already. 2 plus y is equal to 9, and subtracting 2 from both sides gives me that y is equal to 7. So we get the solutions x equals 2 and y equals 7. And that is the solution to that simultaneous equation. This third example here, we've got 2x plus 3y equals 14 and 3x plus 5y equals 22. Now, again, I'll label them up, so 1 and 2. But what you'll notice is there's nothing that I can multiply equation 1 by to make either the x or y coefficient equal to that of equation 2, and there's nothing that I can multiply equation 2 by to make the x or y coefficient the same as that in equation 1. So what we have to do in an example like this is we have to multiply both of the equations, okay, to make the coefficients the same. So the way I would usually do it is, say I wanted to make the coefficients of x the same. Well, the coefficient of x in equation 1 is 2, and the coefficient of x in equation 2 is 3. So I'm going to do equation 1, okay, and I'm going to let's get rid of these highlights. I'm going to do equation 1, and because the coefficient of x in equation 2 is 3, I'm just going to multiply it by 3, like this. And that's going to give me 6x plus 9y equals 42. I think. And because the coefficient of x in equation 1 is 2, I'm going to multiply equation 2 by it. So we get 2 multiplied by equation 2, and that's going to give me 6x plus 10y equals 44. And we can call these new equations equation 3 and equation 4 like that. So now I'm going to do equation 4 subtract equation 3. So 4 subtract 3. And when we do that, we're going to do 6x subtract 6x, which eliminates the x variable, so 0. And then we're going to do 10y subtract 9y, which leaves me with y. And finally, 44 subtract 42, which leaves me with 2. So we get that y is equal to 2. And once again, I'm going to substitute y equals 2 into either equation 1 or 2 to find the value of x. So let's choose, say, this equation here, equation 2. We get 3x plus 10 equals 22, because I've substituted 2 in wherever there's a y. And then subtracting 10 from both sides, we get 3x is equal to 12. And then dividing both sides by 3, we get x equals 4. So we get y equals 2 and x equals 4 as our solutions. And we've solved the simultaneous equations. Now the final example we're going to look at is this one here, where we've got 2x plus y equals 20 and x minus y is 4. So obviously none of the coefficients of either x or y are the same, but we don't always need to make them the same when we've got a positive and a negative. So you can see the coefficient of y here is positive 1, and here the coefficient of y is negative 1. Okay, so we've got equation 1 and 2. So if the number is the same, but we've got one positive and one negative, so in this example 1 and negative 1, or say 3 and negative 3, we can actually add the equations together. So let's do equation 1 plus equation 2 and see what happens. Well, we've got, let's get rid of these highlights again, we've got 2x plus x, which gives us 3x, but here we've got y plus negative y. And if you add a negative, it's the same as subtracting it. So we've got y subtract y, which is 0. So we've eliminated the y variable. And 20 plus 4 is 24. So from here we can divide both sides by 3, and we get x is equal to 8. And substituting that into equation 2, we get 8, subtract y equals 4. So y is going to equal 4. And there we go. We've solved the pair of simultaneous equations. So I've tried to cover pretty much all the different cases that you'll see at GCSE, so hopefully I have. Thanks for watching. If it was useful, subscribe to my channel and check out all the other GCSE videos I've got. And I've got some further maths A-level stuff on there as well, so that's probably worth checking out. So yeah, thanks for watching.